This video is going to give you the knowledge about how to draw the image formed by a convex mirror. So as we know, we need ray diagrams to draw. Before we start drawing, let us know about the rays of light that are usually used to constructing the ray diagrams for the images formed by a convex mirror. So I have taken two convex mirror. This is the center of curvature. Here, as you know, for a convex mirror, center of curvature will be behind the mirror. This is actually our focus. Why it is focus? Because we know if ray which is parallel with the principal axis, after reflection it will follow this direction like this one. It seems to appear that it is coming from this point. So this point is called the focus point for this convex mirror. This is the reflected ray. Here it is the pole. In this case also it is pole, focus point, center of curvature. But in this case our incident ray is actually traveling towards center of curvature, which is behind the mirror. Now if it is traveling towards the center of curvature, as you know, this ray actually here it is 90 degree, so it is normal at this point, so it will reflect back. So by this knowledge we are going to draw the image formed by a convex mirror. Before I begin drawing the images, let me say you something, that as we know that for concave mirror we have got 6 cases. Why? Because we have placed our object at infinity, beyond center of curvature, on the top of center of curvature, in between center of curvature and focus, and then on top of focus, then in between focus and pole. But here, as you know, on the left hand side, that is in front of the mirror, nothing is there. Focus point is on the right hand side, that is behind the mirror. Center of curvature is behind the mirror. Then where do we keep our object? No, that is the question. So here we can take the focus distance, that is, this is the focus distance, no, PF distance. So by that distance we can take here also one point, and this is our reference point. With respect to this point we can keep our object. So we are going to draw the images. So for the first case, when the object is placed at a distance greater than the focal length. So as we know, this is pole, focus, center of curvature. This is the length which is known as the focal length for this convex mirror. So this is the length here on the left hand side in front of the mirror. So we are going to take, here is our object. So if it is the object, we know we need to get the intersection point of the reflected rays. So here we will take, this is one ray which is parallel with the principal axis. It will pass through the focus like this. Another ray which is going towards the center of curvature like this one. So here it is normal, so it will reflect back like this. This is the intersection point, see, here at this point. So here we are going to get our image. So when the object is placed at a distance greater than the focal length, then we are going to get our image, which is virtual, which is erect, and which is diminished. Virtual, erect, diminished. Okay, so let us draw for the second case, when we will keep our object at a distance equal to the focal length of this convex mirror. Pole, focus, center of curvature. So this is the focal length, PF distance. Here I have taken this much distance. So this is our object. Again same, this is the ray which is parallel to the principal axis. It will pass through the focus, reflected ray this one. So another ray which is going towards the center of curvature. So again this ray is normal at this point, reflect back like this. So here we are getting our intersection point. So this is the image. This is object, object, image, object, image. So here also have seen that the image is virtual, erect, diminished. Okay, so for the third case, pole, this one is pole, this is focal length, center of curvature. Now we are going to keep the object at a place when the distance is less than the focal length. So this much is the length which is focal length, so we are going to keep the object over here. Again we will draw one ray which is parallel with the principal axis. It will pass like this after reflection, and another ray which is towards the center of curvature. So it is normal at this point, it will reflect back like this. So here we are getting the image, intersection point here. So this is object, this is image. Again same, virtual, erect, diminished. So all three are same, only we have taken three cases when the object distance is greater than the focal length. Of course the focal length is on the right hand side, but we have to take some reference points, so we have taken the focal length. When the object distance is equal to the focal length distance, and here the object distance is less than the focal length of the convex mirror. In three cases we have got virtual, erect and diminished.